Good morning, everyone. Welcome to my second session on this event. Just a quick question. Who attended my first session about logging? Quite a lot. Okay, probably I couldn't disappoint you then. Today, I will talk about how to fill in the gaps that you can find in PowerShell. It's just very simple ideas. But if you select the correct and handy parameters for your functions, you can build up quite valuable, useful tools for you. First of all, many thanks to our sponsors again. Without them, we couldn't have this event happen. Again, for those who was not attending my previous session, I'm Tibor Soós, a former Microsoft certified trainer and PowerShell MVP. Since then, I'm working in different IT engineering roles. All are related to PowerShell automation. So I basically work with PowerShell since 2006. So since the first public release of it. I'm proud of my Hungarian online PowerShell book and my script tools module, which contains the logging capabilities that you may have seen on Tuesday. Config file management, that's another interesting topic. Unfortunately, that didn't fit in the agenda for this conference, but maybe next year. And today I'll talk about the property management, and there are some other features in it. One of the most interesting one is about a function which enables you to use dynamic properties for your functions and scripts quite easily. I completed a couple of large PowerShell automation projects in the last couple of years. Some of the examples that I will reference today will come from those experiences. In my free time, I'm an enthusiastic amateur table tennis player. Probably you've seen me in the game room sometime. Okay, so let's talk about PowerShell. It has quite a lot of commandlets, but still there are some functions that are missing based on my experience. The search capability among the property values of objects is really a missing feature. It does not require too much investigation how to do this, how to implement this function, but to select the correct parameters for such a function makes it extremely valuable and useful. The second one is comparing object properties. Even though we have a commandlet called compare object, if you think about a little bit, it does not really do that. It does not compare object properties. It compares collections of objects with each other based on a property, but it does not compare properties. So that one should rather be called compare collections, but let's leave it as it is. I created a function that is called compare object property, and that can compare two objects with each other based on their properties. The last one is updating properties. Even though we have add member commandlet, that has quite limited functionality compared to the requirements that I have. So I will show you how I extended that kind of functionality. Okay, so instead of going through the slides, I rather switch to my demo. So searching for properties. You have probably encountered objects which have a lot of properties. For example, WMI or SIM objects, AD objects, especially AD user objects, they have quite a lot of properties. And if you have ever worked with REST API calls and examined the returned response objects, those may also have a lot of properties. And to search among the property values is a challenge. So let's see an example. Here I have a CMI instance object taken from the Win32 operating system class. Let's take a look at that. You can see it has quite a lot of properties. This is in a format list view, and all of these are the properties. What if I want to search for the pattern OPER? By default, we have the format list with the property parameter, and there I specify this wildcard pattern OPER. Let's see what we get. We get 4 properties back, but you can see that the pattern is in the property names, and I can't really use format list to search among the property values. So this is why I developed this search property function. Here the pattern is not a wildcard pattern, but a regex pattern. So it has much more capabilities. And let's see what happens if I execute this statement. By accident, I also have 4 properties returned. But now you can see that not necessarily the name column contains the pattern, but it's rather the value this stage. In the first column, you see some sort of identifier of the object, because you can imagine that I could pipe in not just a single object, but multiple objects. So I should have some capability to differentiate between these results. By default, this column contains the toString representation of the input object, which is in this case not very good because it has quite a generic text. You can imagine that I could actually query these operating systems from multiple computers, and if they have the same operating system, the first column would contain exactly the same text. So it's not a help for us. So let's see a real use case of my search property. Whether is there a property which contains the computer name? So I search for the pattern of the computer name among the properties of this OPSYS object. And here you are. I got 2 hits. The first one is not really a nice one because the SIM instance property contains all the properties of that SIM instance. So it will always be included in the result. So we will forget about it. But the second one, the CS name, is just the one that I was looking for. So it contains the name of my computer. So in my second demo line, you can see that I use the same pattern OPER. Now I override the default content of the object column with the CS name property. In this case, I turn on the case sensitivity so that the OPER should have a capital O in the result set. And I exclude this strange property, SIM instance properties. So if I execute this one, now I get 2 properties with the correct object column. SIM class, creation class name, both contains the OPER with a capital O. Of course, if I want, I can extend my search to search in the property names as well, with this search in property names switch at the end. Now I have 4 properties returned. And of course, you can even update your command line with an exclude values switch. In this case, I won't search among the property values, only among the property names. And here you are. In this other example, I take two AD user objects. I didn't want to make a very complex demo environment, so I don't have a domain controller. I just exported two AD user objects from a domain controller in a CLI XML format, and I will use those as an example. So if you look at that, these are really AD objects. The first one is my AD objects. You can see the name is Tibor Soós. And the second one is Eli Doe, another user. You can see that AD objects also have quite a lot of properties. Here, I use a special notation for the pattern. You can see it's not a literal string here, but it describes that I would like to return all the properties which contain the content of the SN, that is the surname attribute. So it's sort of a dynamic search. This pattern will be actually replaced from one object to the other. So it will be always gets updated in the background. So I'm looking for all the properties or AD attributes which contain my surname, not my, but in general, the surname of the given object. So you can see that the first half of this return set belongs to my AD account. All of these contain my surname Soós in somewhere in the values. And the second half belongs to Eli. Again, the object column now is empty because the toString representation of a CLI XML object is an empty string. So I override this so that it will be the display name. Let's see what we get. And now you can clearly see which records belong to me and which records belong to Eli. Of course, you can set up more complex patterns referencing multiple properties. So here, what are the properties which contain the full name? Full name is a given name plus a space and a surname. So these are the properties which contain the full name. One of the real business use case that I used, or actually this is why I developed this function back in, I don't know, a couple of years ago, because my task was to update the user's email addresses after a migration. And I was curious which attributes contain email-like data. And I didn't want to look at the AD objects for hours, but rather I developed this function searching for the @sign inside the values. And here are the relevant properties. So you can see the mail, proxy addresses, target address, and user principal name contains an email address type of information. So it's quite handy. The next example, you can see that we can, of course, leverage the full capabilities of Regex. So in this example, I'm searching for all the attributes, AD attributes, which contain exactly 3-digit numbers. And here you are. We have object GUID, object seed, primary group ID, user account control. The object GUID and object seed, these are actually a collection of bytes. And these were returned because there is at least one number inside that collection, which is exactly 3-digit long. So this is why those were returned. But in some cases, we are not interested in those. So I added this ignore collection switch so that any AD attribute that is a collection having multiple items in it are now ignored. What is the technology used behind the scenes? It's very simple. You probably know that we have this PS object hidden property, and behind that we have quite a lot of metadata about the object itself, including the properties. And if we look at the content, what we get, we have really all the properties with their names and values behind the scenes. I use this actually in my function, and I search among the values or the names or both, depending on the switches that we selected during the invocation of my function. So it's nothing fancy. What is a little bit more tricky is doing that kind of dynamic search based on the properties of the objects. Here's an example. We have the replace method of the Regex static method of the Regex class in .NET. It has a syntax which takes 3 parameters. The first one is the input string. The second is the Regex pattern. And the third one is a script block. And this script block is dynamically gets updated every time there is a match. So in this example, I'm searching for version numbers, 2 numbers separated by a period. And if this regex finds this first match, 5.2, this $args 0.value will pick up this substring. And you can do whatever you want within that script block. I convert it to be a double, and I increase its value by 0.1. And as the regex goes on, it will find the other version number, 7.5. It will convert that to double and increase it. And this new value, which is returned by the script block, will be the actual replace. What the replace will put it instead of the original substring. So if I execute this statement, you can see that with a single line of code, I could increase the version numbers of PowerShell. This piece of code is actually from my source code is like that. If it's not a literal search, actually we have a literal search switch as well. If it's not a literal search and the original pattern contains this kind of less than, greater than signs and in between something else, then it will strip off that less than, greater than signs from that value, use that remaining as the property name, take that property value from the original object, escape it because it may contain some metal characters for regex. I don't want to have those, so I escape it, and this will be the actual replace value for any it will be the actual new pattern dynamically updated every time a new object is coming through the pipeline. So this is the trick behind the scenes. Okay, so you can see it's a very simple idea, but with these proper parameters, combining that with the regex and the dynamic search capabilities of regex, it's quite a capable function. And if you look at the source code, it's very short. It's just a couple of, I don't know, 20, 30 lines. And it does all of this. So I encourage you to come up with these ideas and extend PowerShell like that. The next one is comparing object properties. This is especially useful to compare not completely different two objects, but rather confirming that an object has changed in the desired way. You may probably have developed some solution which touched some AD user objects, updated some attributes, doing some stuff. and you want to make sure that those changes were implemented correctly. And if you could take a snapshot of the original state and then do your change and take a snapshot after your change, it would be quite handy to compare these two states with each other. And then you will see what were the actual changes in a nice highlighted format. So this is what I did. Here I have a reference object. You can see I have quite a lot of different types of properties in it. It has string properties, a property which contains an array, a property that contains a hash table, properties that contain custom objects, null values, and script blocks. So I try to be as thorough as possible. So this is my reference object. And you can see from your sheets that I have a quite similar object called diff object, having quite similar properties. Could you really detect the differences easily? Not really. So it would take time and maybe you would miss some of the differences. So let's see how my compare object property function works. So if I execute this one, you can see it gave me a little bit of a table having a property column containing the property names. I have a relation column. I didn't want to use the side indicator name because you can see here I have a new type of relation which you can't see when you run the compare object. With compare object, you either have an equal, a right arrow, and the left arrow type of side indicator. But we have here a fourth one, which is this non-equal type, greater than, less than, signs together. Meaning that this specific property exists on both sides, on both the reference and the difference object, but their values are different. Okay, so here we have properties which exist only in one of the objects. So only at diff and only at ref exists only in the respective objects. But the others with this not equal signs exist at both, but their values are different. And you can see it detects all these different types of properties, both the arrays, hash tables, and so on. So in diff hash, you can't really see, even though the keys are the same, but the values behind those keys are different. So this is why this is included in this list. Of course, you can include equals, but before we go on, these R colon and D colon columns are representing the reference and difference objects. And there is nothing after the colon because, again, by default, the two-string representation of these objects should be inserted after the colon. But with these custom objects, it's an empty string. So again, I can select which property contains a better identifier for these objects. In this case, it's the name property. So if I execute this one, now you can see that the column headers are now more intuitive. And because I use this include equal switch, the equal properties are also exposed. You can see in this table that we have some empty rows, at least around the property values. And I needed to hide those. So I added a new option called hide. And here I can select either empty, so hide all the rows that contain empty values. And now you can see that all rows contain some values. Or I hide only those lines where both objects are empty. And now you can see that only at diff and only at ref properties now I got exposed. Or we have an option to hide non-empty. In this case, we get only those properties which are empty in both sides. This seems to be not a very technical term, empty. We haven't heard that before in the context of PowerShell, because it actually contains multiple options. Empty is when the property does not exist for a given object, or if it's null, or if it's an empty string, or if it's an array, or if it's a dictionary type like hash table, but its count property is 0, then I also consider that to be empty. And the last one is empty when it's coming from a database and it contains a systemdb null. So all of these means empty in one word. So these are all will be hidden. The challenge developing this function was that we may have properties that contain objects. Let's assume that we have a reference and a difference property. Both contain PS custom objects. Both custom objects have the same properties with the same values. So if I do a comparison on such custom objects with the equal operator, what would you expect to get? You are out. So I would expect true, because they seem to be identical. But yes, you were right. It's false, because equal is actually a method on these .NET objects. And by default, these PS custom objects doesn't have a very intelligent comparison logic behind the scenes. It just simply compares the memory addresses where these objects reside. And if they reside on a different memory address, then those are considered to be different, so false. But this is not my goal. So you remember, if I export an AD object to save a snapshot of it and load a new one and do the comparison, those attributes will be stored definitely on another memory address. So that's not good for me. So I wanted a more user-friendly comparison. What I did a recursion. So if a property on the reference object is the same as a property on the difference, their types are the same, then I recursively call my compare object property function on those properties. Until, so there should be some termination of the recursion at some point, until I have some basic data types in the properties, like an integer, string, or something like that, which can be compared by the equal operator. So this is my trick. I do a recursion, and that way I can compare this kind of objects which are stored on a different address, but still looking at by a human's eye, they are identical. Unfortunately, there can be some infinite loops of recursion. For example, if you take a look at a script block, it has an AST, abstract syntax tree property. And if I take a look at that, you can see it has a parent property. Okay, let's take a look at what's in parent. And you can see it has a parent as well. And you could actually endlessly continue this expression. And let's take a look at it. It still has a parent. So there is no ending. Unfortunately, I got a lot of errors resulting in endless recursion. So I needed to do something. My trick was to, here I have the source code, to have some hidden parameters for this compare object property. You can see it has a don't show attribute called $_refs, $_diffs, and I calculate some sort of identifier of each object based on the type name and the dash. And in case of file system objects where there is a full name property, I include that. Otherwise, I include the hash code. This is the hash of the memory address where the object resides, and all the property names concatenated. So it will be quite a long string, but this is what I came up with as a good identifier of the object. And I pass this object to that hidden property. It's an array of all the objects crawled through during the recursion. And if that object identifier already exists among the reference or difference objects, then I just quit the recursion so that it won't be an infinite loop. I also terminate the recursion in case there is a runtime type and reflection runtime assembly type, because those cause confusions as well. And to be honest, for the script blocks, I don't even do this recursion termination. In case of script blocks, I just simply convert them to string and do the comparison on them, because there is no reason digging into the properties of a script block. Okay, so there were some issues while I was developing, especially when I tested this on file system objects, endless loops again, and so on. So there were challenges, but now it seems to work. I don't say that I tested on every type of object ever, but the most common ones I tested on. And of course, the main use case of this function is rather custom objects or similar stuff. Okay, but if you use it, try it, you can feedback any issues to me, and I try to improve my function. The last one is the update property, which actually two functions in one. It updates properties of objects, and it also does an update hash. So it handles the keys of a hash table as if those were properties of an object, as you can use PowerShell from a syntax point of view. So you can reference keys of a hash table the same way as you reference the properties of an object. So I take this approach with my function as well, and this update property will update both hash tables and objects. Let's see first a hash table example. I'm a fan of splatting, because using splatting, I can gradually put together all the parameters of a command-letter function, and at the very end, we can actually invoke that command-letter function with all the parameters already collected. So this is a setAdUser example. I want to collect all the parameters for that single statement, and I gradually want to put together the splatting variable. At the first line, I set up the empty hash table, and then I inject the display name and enable parameters for setAdUser with the proper values. For this second update property, I have this pass-through switch at the end, so that it will output the hash table. And we can examine that. Now you can see it display name enabled, nothing special. Let's imagine that I want to set a primary SMTP address for this AD user. In in case of a splatting, there is no direct parameter for proxy addresses. So in that case, I need to use the replace generic parameter for setAD user. And for that, I need to pass a hash table containing the AD attribute and the value. So let's see what happens. Now my splatting variable was extended with the replace. If we look at the replace, you can see I have there my primary SMTP address. What if my processing logic reaches another section which refer to, for example, internal users, and internal users should have a secondary address as well. So this is a completely independent logic from the previous for the primary, and at some point I want to set a secondary address. And this is what I can do. Update property, referencing this, the replace key inside the splatting variable. I say that proxy addresses should be updated, and this is the secondary address. If I invoke this one, what happened? It didn't overwrite the proxy addresses. It extended the current value. This is what generally we want to achieve. So previously it had a simple string content, and my update property function converted that single value to be a one element collection and added this new value to it. It's perfectly suitable for this use case. What if I want to add a third SMTP address? Now I use a slightly different syntax, so I could even reference the splatting variable as the object, as a target. And in that case, the prop name is the replace key. And in that case, the value is a similar hash table as I used during the first example. So let's see what happens. I select these two lines together. And again, there was no overwrite. It just extended the value with the new one. If I mistakenly execute this line again, nothing happened, because my function ensures that there will be a unique set of values behind those keys. So there is no reason adding the very same address multiple times. setAD user will complain most probably. Okay, so let's assume that I want to change my mind, and instead of using Hungarian characters, I just want to use English characters in my name. In this case, you can see I use the force switch, meaning that I don't want to have this logic to convert the existing value to be a collection and add the new value to it, but I just want to simply override it. And in that case, you can see now it's overwritten. What if I want to clear certain attributes, for example, title and department? Now those values are added. What if I want to extend the properties or AD attributes that should be cleared with the manager, but I mistakenly left the department here? It didn't cause any issue. Again, update property makes sure that there will be a unique set of values. So it was skipped. So I could go through my whole user processing logic, and at the end, I have a safe content inside my splatting variable. So this is one of the use cases. By the way, have you ever used update list commandlet? Are you aware that there is an update list? Poor guys. We have one, and it has an extremely limited use case. It works like similarly to my update property, but it will fail nearly every use case. So it is intended to extend values of properties which contain a collection. So this is similarly when I added the secondary SMTP address. This is the use case. The only problem that the property, the collection in the property, must not be fixed size. But in general, PowerShell uses fixed size collection by default. The only exception is the AD module, which loads the AD objects, and those properties or attributes are extensible collections. So this is the only use case for AD objects, but it won't do this kind of making sure that there are unique values, and it won't do the other tricks. Anyway, so my update property is sort of a add member plus update list on steroids. Let's take a quick look at the other example. Let's imagine that I'm processing requests coming from a service desk system. Here's a very simple request, ticket number, description, and 3 requested items. My goal is to count the valid items inside the request, because if it turns out that there is 0 valid items in it, we can just simply close it or cancel it or whatever. I need to collect the approvers who should be determined during processing. The logic is all the managers of the owners of these privileged accounts should be the approvers. But notice that I'm the owner for 2 items, so it should be only a unique set of approvers collected. No 2 times my manager. And the last one is to extend the items with the distinguished name of the owners. So these are the goals, and my preference is not creating variables storing information around these kind of objects. Because these are objects, it's quite handy that we can extend them. So if there is an information that we calculate but belong to this specific object, I rather prefer to add a new property and store the information together with the object. Because we can then now pass this object to another processing step, and it will have this new information included, embedded in the ticket object as well. So here's my ticket. I also load the AD users, hash the AD users by their display names so that I can easily search for them based on their display names. So this is the initialization of my demo. And here's the processing part. I go through the requested items one by one. There is no validation logic here, but you can imagine that here in this command block I would have the validation. The first update property creates the counter. You can see I don't use a value parameter. The value with the default value with update property is an integer 1. And if there is an integer on a property which I update the next time, the default logic is not creating a collection and add a new element, but in case of integers, it will just add those numbers together. And by this single line, I will create a counter, because during first execution, it will create this count of valid accounts property and assign a value to 1. During the next iteration, it will just increase the existing value by 1. So this is a simple counter. I determine the approver, and I just simply assign it to the approver's property. And the update property will make sure that there will be no duplicates. And the last example, I calculate the distinguished name of the owner, and I just simply assign it to the item. You can now see the target is the item. In the other 2 cases, the target is the ticket itself. I went through the items, and now you can see that the ticket object has this count of valid accounts property with the content of 3. And you can see here I have only 2 approvers. One is Joe Smith and the other is Billy Boss. And if you take a look at the requested items, here are the original attributes, and that was extended by the owner DN. So these are the 2 use cases I developed this update property, and that way my script processing can be very simple, and all the heavy lifting is done inside update property for these common use cases, like making sure unique values and so on. Okay, unfortunately we ran out of time. Of course, I'm available for you if you have any further questions. You can access this module through my GitHub link, and I also upload it to the conference GitHub repo as well. Feel free to reach out to me via email, LinkedIn, whatever, if you have any questions. Thank you very much.